Given the complex numbers z, which is 3 plus 5i, and w, which is 2 take away 3i, we want to find the following. And the first thing is the real part of z. Well, if we look at z, 3 plus 5i, the real part is just 3. The imaginary part of z, which is what we want in part b, is just going to be the coefficient of I, and so that is 5, positive 5. Moving to part C, we want the conjugate of w. So the real part will be the same. The imaginary part needs to change sign. And then we want in part D, we want z bar. So the real part will stay the same. The imaginary part will change sign. Now we want to calculate WW bar. So that is going to be 2 minus 3i, 2 plus 3i. That's a difference of perfect squares. If you expand out the cross terms, so that's this one and this one, would cancel out. We've got positive 6i minus 6i. So we only really need to do, remember with the difference of perfect squares, you have a minus b, a plus b is just a squared minus b squared. So this one is going to be 2 squared, take away 3i squared. Now 3i squared is going to be 9i squared, which is negative 9. So we have 4 take away negative 9, which is 4 plus 9, giving us 13. Z bar, or z bar z, 3 minus 5i, 3 plus 5i, and in the same way as the other one, that's going to be 3 squared, take away 5i squared, so that will end up being 9 plus 25, which is 34. Now we're going to use the results down here in the next example, and it's an important result, and we'll talk about that later as well.